Hello, geometry. We will be going over those quizzes and homework checks tomorrow when I return. They are graded, they are in the grade book, so if you want to check your grade, they're already in the computer. At any time during this video, if you have a question or if you need the substitute teacher to pause the video, just raise your hand. That will be the cue to the substitute teacher to pause the video. Don't say anything, just raise your hand and they will pause the video. Looking at this screen, I'm going to go through some of the main points from your quiz of how to find missing pieces if I have a certain triangle. Notice how in the first one I have a 45, 45, 90 triangle, and I only have one equation that deals with that, or one formula. Hypotenuse equals leg times root 2. Now notice how if you have congruent angles, you should have congruent sides in a triangle. So this 9 is going to be the same as y. So the only kind of mathematics that I have to really do is solve for the hypotenuse. I put x in place of the hypotenuse, 9 in place of the leg, times root 2. Notice how the variable is by itself. So my answer is x equals 9 root 2. And like I said before, the variable y should be the same as the other leg. We forgot a lot about that on the quiz yesterday. Next triangle, we still have a 45, 45, 90 triangle. If I have two congruent angles in a triangle, that means I have two congruent sides, and it's these legs. So the variable y will be the same as 2 root 2. I will strictly be solving for the hypotenuse. I will put x in place of the hypotenuse and 2 root 2 in place of the leg. I have the variable x by itself, so what I need to do is simplify this if at all possible. In the previous example, notice I just had a coefficient and a radical. I cannot multiply those. One's a coefficient, one's a radicand, can't do it. In this one, however, I have two radicands. I'll take square root of 2 times the square root of 2. We know is going to be the square root of 4, which is the same as being a 2. So x is equal to 4. In this bottom example, we've got a 30, 60, 90 triangle. So I've got two formulas. But what's really important today is noticing what is your longer side, what is your shorter side. So if I look at the 30 degrees, the side opposite of 30 degrees is x. So this is the shorter leg, this is the longer leg, this 15 root 3, and then we've got the hypotenuse y. I just realized I wrote all that on example 4 instead of example 3. So if you could just take this part in, how opposite of the 30 degrees is x. Because I only know the longer leg right now, the formula using longer leg is equal to the shorter leg times root 3. Notice how I put 15 root 3 in place of the longer leg, x in place of the shorter leg, and now this variable is not by itself like these previous examples were. So I'm going to have to divide both sides by the square root of 3. And we get the shorter leg being 15. Well, if I know the shorter leg is 15, I'm only going to have to double it to get the hypotenuse. So y is equal to 15 times 2, and therefore y is 30. Let's go on to notes. So get out your notes packet. You may want to pause it right now until the students get out their notes packets. But today is day 7. We're going to learn about trigonometric ratios. First off, a trig ratio is a ratio of the lengths of two sides of a right triangle. And we need to be able to identify sides of a triangle. The leg that is opposite of this angle A, so if I can locate an angle, so if there was 23 degrees inside this angle, the leg opposite of A is the one across from it, or one that does not form the angle. So a side that does not form B is this side B. A side that does not form this right angle C is the hypotenuse C. In order to do trigonometry, we have to be able to recognize opposite sides from an angle. So we're going to go through what is tangent, sine, and cosine of an angle. Notice the triangle over to the right. How if here's my angle A, so it's different than your previous picture. because we have triangles that rotate all the time. So if your angle A is in the bottom left, the side opposite of angle A is the one that is not creating it. The side opposite of B is the one that's not creating it. But if I concentrate on angle A in every single one of these examples, A is the opposite to angle A. The longest side, or the side opposite of the 90 degrees, is called the hypotenuse. But then this B is called adjacent to A. So when you see the word adjacent pop up, that's where we're at. So tangent of A is opposite, the opposite side divided by the adjacent side. So if I'm representing the opposite side with the letter A and the adjacent side with the letter B, it turns into a fraction A over B. It's a ratio to these two sides. The sine of an angle deals with the opposite side over the hypotenuse. So we use the letters, the opposite side compared to A is A, lowercase a, and the hypotenuse is labeled with a C. So there would be a number here. Cosine of A is adjacent, the adjacent side to A, so it's going to be B, over the hypotenuse, again, would be C. So it would be a fraction of B over C. We've learned this, you've heard of SOHCAHTOA. And we'll be talking about this a lot. But SOHCAHTOA comes from trying to help you remember that sine represents the opposite over adjacent, cosine represents adjacent over hypotenuse, TOA, so tangent, is opposite to adjacent. It is also represented by this, SOHCAHTOA. So in the first example, when we're finding the cosine of S, sine of S, tangent of S, we notice what angle we're concentrating on. It'll be extremely helpful if we can maybe make an arc with our angle that we're concentrating on, because then the side opposite of S is 3. The hypotenuse is 5. And 4, in reference to S, is adjacent. So if I'm looking at cosine, and if I try to remember, okay, SOHCAH, that's C-A-H. So if that's adjacent over hypotenuse, it's going to become the fraction, well, what's in the adjacent spot? 4 to 5. And then I try to remember sine, so that's opposite over hypotenuse, which turns into 3/5. And the last one, tangent, TOA, opposite compared to adjacent, it's going to be the ratio of 3 to 4. Next example, if I notice that the angle I'm concentrating on is R, let's mark it in the picture. And let's also notice where the opposite side is, where the hypotenuse is. Hypotenuse is always across from the right angle. And where now, the one that we're kind of learning that's new is what the adjacent side is. Tangent is opposite over hypotenuse. So it's going to be the fraction 6/12. Ooh, but we can take that a step further and say that that's 1/2. Sine is opposite. Ooh, hold on a second. Let me back up. Tangent is not opposite over hypotenuse. Tangent is opposite over adjacent. So I need to have 6 over 8, but I still can reduce that to 3/4. I noticed the red flag whenever I got to sine, because sine, so, S-O-H, is opposite over hypotenuse. So this is 6 over 12, which reduces to 1/2. And cosine is adjacent compared to hypotenuse. So we've got 8/12, and if we reduce that by 4, we get 2/3. So let's talk about using your calculator. You're going to use sine, cosine, and tangent. By the way, we say sine, not sin. We say cosine, not just cos. We say tangent, not just tan. So these are the abbreviations. We're going to use those, and we're going to make sure your mode is in degrees. I think everybody's default mode is already in degrees. So we're going to approximate these values to 4 decimals. What you need to do, some of your calculators, you're going to have to hit 35 and then hit tangent. But if you have those blue calculators, you hit your tangent button and then 35. You should get 0.7002 approximately. Be sure you can do this. Substitute, you may have to pause. The next one, we're going to do cosine of 85 degrees. And then we're going to do sine of 10 degrees. Be sure you get the following 2 values. Again, pause so you can make sure the students have this. First example is we're going to be given with an angle, or we're going to be given an angle and then 2 sides. And we're going to have to find a missing side using sine, cosine, and tangent. So if this is the angle I'm concentrating on, I have to realize what sides I'm given. In reference to 22, that 3 is on the opposite side, and the x is not the hypotenuse, it is the adjacent side. So I have to come up with a trigonometric ratio that involves the two, and it's tangent. Tangent of the angle 22 degrees is going to be equal to the opposite side, or the opposite side 3, over the adjacent side x. And we're going to have to plug this into our calculator and then put it over 1, cross multiply and divide. So let's put tangent of 22 degrees in our calculator to get the value of 0.4040. The next step is putting that over 1. Then we will cross multiply, taking x times 0.4040 and 1 times 3 and setting them equal to each other. This turns into 0.4040 times x equal to, well, 1 times 3 simplifies to 3. Notice how the variable is not by itself, so I'm going to have to divide both sides by this decimal. So when I take 3 divided by 0.4040, I get 7.4. Notice how the direction said round your answer to the nearest tenth. That is 1 decimal place. So it should round 7.4. Again, depending on when you round, if you don't round, I round it along the way, so I think everybody should get 7.4 in their calculators. Next example. We look at the angle that's given to us at 32, and then we see, okay, what's being labeled? We have this x and we have this 10, and we have to figure out what is it in reference to 32 degrees. Well, x in reference to 32 degrees is the opposite side, and the hypotenuse is 10 because it's across from the 90 degrees. So a trig ratio that deals with opposite and hypotenuse is sine. I will be taking sine of that angle 32 and setting it equal to the opposite side and dividing it by hypotenuse. So opposite over hypotenuse. Again, I'm going to have to plug this into my calculator. You should get about 0.5299. I will then put this value over 1, cross multiply and divide. So I simplify each side, like what is 10 times this, what is 1 times x, and we get 5.299 equal to x. Notice how I have x by itself equal to a value that's simplified. So actually, I just need to round to the nearest tenth, and we're about 5.3. That would be my answer. Your homework tonight is going to do the following examples either with the substitute or on your own, depending on what the class decides or what the substitute decides. So the following examples are as follows. You will have to pause along the way so the students can get the values down. Next example looks like the following. Next example looks like the following. Example 10. Example 11. Example 12. Example 13. You will have those to do as homework, and we will check them immediately tomorrow.